This here is a super high voltage magic wand that I've made. And if you're asking why, well, because months ago I've received an email from Vsauce 3 YouTube channel for a cooperation video on the Harry Potter episode. But since I live in Spain and their office is on the other side of the world, our online meetings were impossible to make during working hours, so we never made that cooperation. Actually, the Electroboom YouTube channel got to make such a project, and I'll leave the link for that video below the description. But since I've already ordered all the material for such a project, the PCB, the high voltage capacitors and the diodes, the generator, well, I'll make this project as well and maybe teach you something new on the way. What is a voltage multiplier, how to get high voltage with some transformers, and what you could do with such a magic wand project. So have in mind this might be dangerous, so if you're not sure about something, don't make it, and always use proper tools and never touch the high voltage components. So guys, let's get started. Your projects will be a lot better if you use the services from PCBWay for prototyping boards, for soldering your components with the SMD assembly service, or the Steel SMD stencil for soldering the components yourself. Or maybe you want to try their flexible PCBs, or the new services with 10% discount for CNC machining or 3D printing, together with laser metal cutter and bending, and also mold injection parts. I've just received my PCBs from PCBWay and they look amazing, especially with this new purple color that I've tried, but you can select any other color from this list. They have a very fast production time, so you can have your boards in less than 10 days, and the best of all, starting from only $5. What's up my friends, welcome back. A magic wand like this one has three main parts. The DC supply, which can be a normal battery like this one. Then we need to elevate the voltage with some sort of ZVS circuit for the high voltage generator. This is usually made with flyback transformers, and it creates high frequency, high voltage. This voltage is AC and is also quite dangerous. The third part is the voltage multiplier. And for that part I've made my own PCB, so it would look better and it will be easier to make. The multiplier is using a series of voltage doublers that are made with diodes and capacitors. So let's go step by step and I'll explain you how each part works. And as I've told you, for the voltage multiplier I've made my own PCB and order it at PCBWay. If you want to make the same PCB, download the Gerber files from below for free, and then you can go to PCBWay.com and click here the Code Now button. Then select your settings for the thickness, the amount of PCBs, the color of the solder mask and save to cart. On the next page upload the Gerber files and make the order. Receive the PCBs in just a few days. Okay, so let's make this project. We need a battery capable of delivering enough current. This 18650 can easily deliver 10 amps, and that's why I'll use this one. But I want more than 4 volts, so I'll use 2 of them in series. Together with the batteries we need a charging module, so for that I have this 2S BMS charger. We need to connect 8.4 volts to this module, and since I want to use a charger with a USB connector, I will also add a boost converter module to raise the voltage from 5 volts to 8.4 volts. So we would have a series of the USB cable, then the USB connector, the boost converter, the 2S BMS module, and then the battery pack of 2 cells. Okay, so for now we have the DC power source. Let's check the high voltage generator. For that we can make our own using a flyback transformer. You can see how to make one in a few of my previous videos, so check those in order to know how it works. I have for example this flyback transformer, which is way too big for this project. But I also have this smaller flyback transformer that I've took out from some LCD screens, but these are too small and they can deliver enough power. What I could use are these module generators that I've used with my shocking game project. The secondary is okay, but the primary might have too many loops, and the wire is not that thick. So you might want to rewind this with less loops and a thicker wire for more power. Something like 10 loops for the primary and 20 loops for the flyback coil with a thin wire. The circuit is something like this, and this is just an oscillator that is made with a transistor, a diode, a resistor, and the flyback signal from the transformer. And this would create high frequency and high voltage. And since this is high frequency, it won't shock you, but it will burn your skin if you touch it, so be careful. The PCB of this module already has the circuit. The problem with this module is that it has no insulation and is made to be used with below 5 volts. But I want even more power, so I want to use it with 8 volts. And at that voltage the arcs would be forming between the windings of the secondary and it would burn out, as you can see right here. A solution is to submerge the entire transformer into some sort of resin. And that would insulate the coils and no sparks would jump. I've also bought some 2 components resin, and we could use this to submerge the entire module inside that resin. But if you don't want to go over this mess, you can directly buy a module like this one. This is already submerged into some kind of resin, so it's very well insulated, and it works okay with 8 volts, so we can create higher voltage. Make sure that you buy a small one like this one here, because the big one already has a capacitor multiplier at the output, but we want to add that part ourselves. This is the difference between the outputs. The small one creates continuous high-frequency plasma arcs, but the big one creates pulses of high voltage, so it must have some sort of capacitor at the output. Okay, so now we have the DC power source and the high voltage generator. The next part is the voltage multiplier, and that is made with such configuration. We have 2 capacitors and 2 diodes and the AC voltage at the input. On each AC peak, one of the capacitors will charge up, and then the voltage will sum up, creating double the value. And this will be ideally, is never exactly double the value. So if we add more stages, we can double the voltage each time. In my case, I've made my PCB to have 7 stages, so it could double the voltage 7 times. So let's say that the transformer is outputting 10,000 volts peak to peak. At the output of the 7-stage multiplier, we will have 140,000 volts, more or less. And I could also merge together 2 of these PCBs in series and have a 14-stage multiplier. To make these multipliers, we need high voltage capacitors and high voltage diodes. These, for examples, are 15 kV capacitors of 330 picofarad. And these here are 10 kV diodes. And all you have to do is to follow the silk layer on the PCB and assemble the multiplier. We add all the capacitors and then all the diodes. And make sure that you don't place the diodes backwards, so check the cathode line on the silk layer of the PCB. And just to make sure, I've made 2 equal PCBs, and I might merge them in series in order to get higher voltage at the output. So now all 3 parts are ready: the DC supply, the AC high voltage generator, and the voltage multiplier. So it's time for some tests and then assemble it inside on some sort of enclosure. I've connected the multiplier PCBs in series by soldering together the pads on the back. I connect the high voltage generator at the input. And look, every time I connect my supply, I can push some paper with the electron flow. The wind is very strong and I'm only using 4 volts for the input. But one main problem is that the components have a lot of sharp edges, so a lot of the electrons can escape, so the final output is affected. So to minimize losses, we could submerge this entire circuit into the 2-component resin for insulation. I've 3D printed this Magic Wand case. It will have spaces for the battery, the transformer and the push button. And on the rear part it has a space for a USB connector so we could recharge it. The wand part was printed with transparent PLA, so we could see a little bit inside of the wand. And I also want to add some LEDs inside, connected to the same push button, so we should know when the wand is active. So download the 3D files from below and print them with some PLA material. Okay, now let's assemble it. The plastic case of the wand is made out of 3 parts. For the USB connector, I will use the board of this old module that doesn't work anymore, so we solder 2 wires to it. Then I glue this module inside of the 3D case. I also test if I can connect the USB cable. Then I connect these 2 wires with ground and 5 volts to the boost converter. Using the multimeter with the USB cable connected and rotating the boost converter potentiometer, I set the voltage output at 8.4 volts. Then I connect this output to the 2S BMS module. And the BMS module is connected to the batteries. And from the BMS we have 2 wires output for 8.4 volts, and this will go to the push button. And from the button it will go to the high voltage module. And also from the push button I solder a resistor and 3 blue LEDs, and that will glow inside of the resin. I fit all this circuit inside of the bottom part of the 3D printed case. On top of this case I want to have the 2 wires from the AC generator and those 3 LEDs. For now this is just like a powerful arc lighter. So now we can add the voltage multiplier. So I solder it and fix it in place more or less. Now I can add the transparent 3D printed part on top. And this was printed in vase mode and using the Polymaker transparent PLA material. This PLA can get almost transparent when it's sprayed with some alcohol. Since it was printed in vase mode, this will be quite fragile, but the resin inside it will make it stronger. I use it just to give it the shape of the wand. Now that I have it in place, we prepare some resin. I mix 3 parts of the resin and 1 part of the activator. And now we fill the entire wand with resin. But in my case there was a small leak at the bottom part, so the entire resin got out and made such a mess. The push button was damaged, so I had to remove it and add some more wires. And to these wires I had to add a new push button. But also unfortunately I've dropped the wand on the ground and broke it. It still works, but I think I should make a new one, so I had to start this all over again. So just to make sure I've 3D printed the wand again. I've made the same connections as before but with a different battery, the same high voltage module and the boost converter. Then I've placed them inside of the new 3D printed wand and glued them in place. I've made 2 more voltage multipliers. But this time, in order to save some time, I've covered them with some spray varnish, applying a few layers, because the resin would take around 3 days to get fully hard, so if I fill this new one with resin once again, I would never finish this video. At the tip I've placed a round shaped metal. Okay, so now let's see some more tests, and once again, be careful. Also, please don't use this close to any electronics, otherwise you might fry them forever. This thing is very powerful. The first test is directly on a metal with the earth connected, and as you can see some huge sparks are jumping off the tip of my wand. Now I place a high voltage capacitor suspended in mid-air, and without touching it, some arcs are forming between the pins of the capacitor. There are so many electrons flying away that the capacitor could charge itself till the point where it creates a high voltage arc between its pins. And by the way, some electronics around my workshop, such as my power supply, starting clicking, even from a few meters away, so be careful. The next example is with some paper. As you can see, we have enough electron flow that we can push the paper without touching it. You can make some cool science examples with this wand, as for example, when I touch my workshop table, I can then attract the paper with my hand. And this looks like magic. And the same would happen with some sand and maybe some aluminum foils. Also the same with this candle flame. The electron's flow is powerful enough to move the flame. Or it could even put out the fire. In this example you can see how I can charge my clothes so they get attracted to my skin. As you can see, the shirt is attracted to my body, and I can really feel the powerful wind on me. You have everything that you need to make this project below in the description. My schematic, the part list, my 3D files, the Gerber files for the PCB, and the step-by-step guide, so check electronoobs.com for more. I hope that you have learned something new, and if so, give me a like or comment below. Thanks again and see you later, guys. Hey, so one more video that ends, I hope that you like it. Okay, so listen, if you want to buy my merch, my t-shirts, you have the links below for my shop, and I promise that I will make more designs. And also maybe you would comment below which one you like more and what more designs you would like to see, because in that way I could start designing them and post my new t-shirts. So thank you for all the support, and I'll see you in the next video.